Good afternoon, students. Welcome to our new session. So, last class, what we have discussed, it's about the definition of pharmaceutical analysis and types, that is qualitative and quantitative analysis, and their methods, the microbiological methods, biological methods, volumetric methods, etc. Then certain definitions like a titrant, what is endpoint, equivalence point, etc. So I told you to make one summary of the last class. Hope you all submit it. So in today's class, we are going to discuss about significant figures. Also, certain methods for expressing the concentration, and finally some titration. So significant figures. So before telling about significant figures, I like to give you one example. So we are taking one cylinder for measurement. So length of our duty is to measure the length of the cylinder. So one student noted as 3.2, another student noted as 3.20, and the last one noted as 3.200. So these digits or these measurements are different. We'll got three different measurements. So which is more precise measurement? 3.200 is most precise measurement. So because that student added significant figures or significant digits more. So significant figures means adding digits to our measurement or a result for making them more precise. That is called as significant figures. If we didn't add significant figures means our answers or our results will be not accurate. There will be some errors. So it is very important to know about significant figures. 0 means it is a significant figure. See one example, there is 1.2680. So this is significant, and this one also is significant. And these zeros, 0, you can see these zeros are significant. And another example, there is 0.0025 kilogram. These zeros are not significant because this zero's duty means it is to locate the decimal point. So some people will omit these zeros and they will write as 2.5 gram. The same example, see 1.2570 and 1.0056. These are significant. So how many significant figures you can see here? There are 5 significant figures you can see here. And another example, that is we are doing one titration. So we'll get 20.5 ml and 20.7 ml. So some people will write as 20.6 ml. So that is okay, that is correct. But we cannot write as 20.60 ml. If we write as 20.60 ml, it could be indicate that the volume will lies between 20.59 ml and 20.61 ml. So that is completely wrong. So we can write as only 20.6 ml. So that is most precise result or measurement. Next one, there are certain rules for the significant figures. So all non-zero digits are significant. Non-zero digit means the digits without zeros. For example, 126. This is a non-zero digit. Or 361. It is a non-zero digit. So these are significant. Then zeros between non-zero digits are significant. For example, this 102. So 1 is a non-zero digit and 2 is a non-zero digit, and in between 0. So these zeros are significant. Then loading zeros are not significant. See, this is loading zeros. because the duty of these zeros is in order locate the decimal point. Next one, these 5.40 means that after decimal point some zeros will come like this. So these zeros are significant. Next is rounding of significant figures. See, this is the example. If the last digit is written less than 5, see 3 that is less than 5. So there will be no change in it. That is, we can write 76.8. No change. If it is greater than 5, see this is greater than 5. So it will be increased by 1. That is 59.9. Next, if it is last 5 only, last digit, see this is 5. Then also we can increase by 1. That is 69.8. Next one, odd number and even number. Odd number means there will be increase in 1. Even number means there will be no change. So in case of odd number and even number, we used to consider this one. That means the digit after decimal point, the first digit after decimal point. So this is even number. So there will be no change. If it is instead of 2, it is 5, 3 like that, there will be increase in one digit. That is, it may be 68.3. Sorry, if it is 3 means it will be 4, 68.4. And that's about the significant figures. Next, addition and subtraction in significant figures. So in addition and subtraction, there will be many decimal places. See, you can see this is one of the example. You can see many more decimal places. But after addition and separation, our answer should have only one decimal point. See, this is our answer. So this should be have only one decimal point. So we can finally round up as like this. Then multiplication and division. In multiplication and division, there will be no changes. The result is same as what we get. See, while multiplying this, we are getting 7.30355. So we don't want to write as such as what we got. We can make it as 1.73 kg. Because there are only 3 significant figures here. So we don't want to write completely. Then, methods of expressing concentration. So there are many methods for expressing the concentration, I mean solution concentrations. That is normality, molarity, mole fraction, percentage, molality, formality, percentage weight by weight, percentage volume by volume, percentage weight by volume. First one, normality. Normality we can denote it by n. So normality means it is a number of the solute that is present in the 1 liter of solution. Actually, it is mainly used for acids and bases. Mainly it is calculated for titrations only. So normality value always related on the solute role in the solution. So there are 2 formulas for calculating the normality, that is number of gram equivalents of solute divided by volume of solution in liter. Another formula, weight of the solute in grams divided by gram equivalent weight of the solute into volume of solution. You can select any one formula and write. Then molarity. Molarity can be denoted by letter capital M. That is number of moles of solute present in 1000 ml of solution. Molality means it is by small letter m. It is the number of moles of solute per kg of solvent. And the formula of both, there is molarity formula, masses of solute divided by volume of solution in liter, and molality, moles of solute divided by mass of solvent in kilogram. Then mole fraction. Mole fraction means number of moles of solute divided by total number of moles in the solution. For example, number of moles means if there will be A, B, it is the two different type of moles that is present in the. So how we will write the formula? That is number of moles, that is Na plus Nb divided by Na Nab, like that. Percentage weight by weight. Weight means it can be calculated in grams. So number of grams of solute contained in 100 gram of solution. So formula will be weight of the solute divided by weight of the solution into 100. Then percentage volume by volume. It is milliliters volume. Milliliters of the solute. Number of milliliters of solute present in 100 ml of solution. So formula will be volume of the solute divided by volume of the solution into 100. Next is percentage weight by volume. It is weight means grams. So volume means ml. So grams of number of grams of solute present in 100 ml of solution. That is weight of the solute divided by volume of the solution into 100. So these are the methods for expressing the solution concentrations. Then fundamentals of volumetric analysis. So as we discussed earlier that there are many types of reactions: acid-base reaction, redox reaction, precipitation reaction, complex symmetric reaction, etc. So mainly 4 reaction. First one is neutralization reaction. It is acid-base reactions. So it is nothing, it is a combination of H positive and OH minus, that means acids and bases, and they results to form water. That is called a neutralization reactions. So there are two types in it, that is acidimetry and alkalimetry. Acidimetry means it is the titration of the weak acid with standard acid by the process hydrolysis, or it is a titration of free base with standard acid. That is called acidimetry. Then alkalimetry. Alkalimetry means it is a titration of weak base with standard base, or we can say free acid with standard base, using the process hydrolysis. That is acidimetry and alkalimetry. Then redox reactions. Second one. Redox reaction means it involves, that means changing the oxidation number of the reactants and product. So always the electrons will transfer from reducing agent to oxidizing agent. So there are many examples for the redox titrations. If you are doing it with potassium permanganate, we can call it as permagnometry, or it is with potassium chromate means it is chromatometry. Ceric salt means cerimetry. Iodine means iodimetry, and potassium iodide means iodometry. Then precipitation reactions. That means it is a combination of ions to form precipitate. For example, the titration of the silver nitrate and chlorides, it is NaCl or KCl. So there will be no change in the valencies during the reactions and all. So this is the reaction. So these type of reactions, that is called as precipitation titrations. Complex forming titration. Complex forming titration means it is a combination of ions to form complexes. That is called a complex formation titrations. For example, we have silver and we have cyanide. So these are different ions. So they combine to form a complex, that is silver cyanide. Then using the silver cyanide, we are doing our titration with silver nitrate. So that is called complexometric titrations or complex formation titrations. So we'll study about all these type of titrations later detailing, because the chapters are coming. So that's for today. Thank you.